Hello, my name is Mark, and this is my helper Kate, and we're with Stevenson PACT Elementary School, and I'm going to demonstrate to you about pressure and water, okay? So, with water, there's three phases of water, okay? Now, normally we see as water is what you drink, okay? You're going to have basically water molecules, right, that are in, like, let's say in the glass, okay? And this is free flowing. So what that means is, like, when you could spill it, but it doesn't really separate really easily. But if you have it really cold, right, what happens is it turns to ice cubes. And with that, with the temperature, these molecules are in a very solid structure. You can't move it. It's just a solid, okay? So this is a solid. A liquid. Now, if you heat it up with a flame, okay, what happens is the water evaporates into gas, okay? And what happens when you do that is you put energy into the liquid to produce the water into water vapor, okay? And what happens is these water molecules, they get excited and they want to bounce around, so it actually creates it needs a little space, because if a kid is energetic and they run around a lot, they need more room, right? Whereas if a kid it's still, they don't need as much room. So what happens is there's more pressure. So for a good example would be if you heat hot water in a tea kettle and it starts boiling, it's creating pressure in the kettle. There's a whistle inside the nozzle that creates the whistle noise. Like when you blow a whistle, same thing with the tea kettle, is the pressure builds up and escapes from the kettle and it makes a whistling noise. So what I'm going to demonstrate to you is what happens when the gas cools down to a liquid. So I just mentioned that when you heat it up, it turns to a gas, it expands, okay? So to demonstrate, and you can do this at home, is I just have a water bottle, right? Make sure that it has a lid that you could actually do very tightly. And I have hot water, so I'll be right back. I'll get hot water.
Okay. Should I just turn it off?
It's not.
Wait, oh, you're that way?
And I have hot water here, okay? And so what I'm going to do is I'm going to carefully, in this bucket so I don't have it on the ground, is to pour hot water inside of the water bottle. And make sure you're having enough water inside the water bottle. And kids, have your parents do this if you want to do this, okay? Because hot water is very dangerous, it could burn you. Okay, so I have a little bit of hot water here. And now, make sure that all the gas is hot inside, and go ahead and start screwing it in, Kate. Thank you.
So hot.
Yeah, it's pretty hot, okay? And so, it's pretty hot, yes. And so, I'm going to screw it on really tightly, okay? Now, what do you think is going to happen when this hot gas, basically it's a water vapor, it's really hot, what's going to happen when it cools down? So what I do have here also is I have a bucket full of cold water, okay? And it's okay, why don't you put that the bottle into the cold water? And do that for a little bit. And what's going to happen is, you'll see is, oh, you hear that noise? What's happening? Okay, so I want you to pull it out, Kate, and see what's happening. Oh wow, look at that. So it's already happened, okay? So you see, look at that. So see how the water bottle is actually collapsing? So let's do it a little more. So it's a little warm, okay? Okay. And you don't have to put it in water, in a bucket of water. You can just leave it out and let it cool down itself. It'll do the same thing. I just want to accelerate it. And see that? So what's happening is the gas molecules are cooling down and they're turning back to liquid. What happens is, if there's less excitement in the air, in the water molecules, what happens? It goes down to gas, and the pressure goes down. Same thing with the opposite of what happens when you actually boil the liquid, the water to gas. So it creates a vacuum. You see that? So you can try that at home, kids, and see what happens, and see if it gets the same results. Okay? Thank you. Bye.